Good morning. Let's get into experimental probability. I think experimental probability might be a little bit easier because you are actually doing experiments. You're actually rolling the cube, you're flipping the coin, you're spinning the spinner, and you're recording all your data. And you have to organize it into a table. So let's go ahead and press pause. You can actually copy this and this part right here. Yeah. And then wait for the bottom part because we're going to do, you have 1, 2, 3, 4 examples with this one table. So press play when you're ready. So experimental probability. This one is what actually does happen. So theoretical is in theory. You're just thinking about the coin and visualizing what is on the coin and what I should get if I were to flip it. Now you're actually flipping the coin and recording your data. I flipped the coin 20 times. 10 times I landed on heads. The other 10 times I landed on tails. Sometimes it's not going to be exact. So theoretical probability is like in a perfect world, this should happen. Experimental is close to it. If I do enough experiments, enough trials, we call them, eventually I will get very close to the perfect theoretical probability. So experimental, it's also written as a ratio of the number of times an event occurs to the total number of trials. So the bottom number is not going to be how many total outcomes I have. It's going to be how many trials did I actually do? How many times did I flip the coin? How many times did I roll the cube? How many times did I spin the spinner? So that's the big difference here. Then the top number is still going to be the number of times the desired outcome occurs. So now I have to look at the data. Okay, how many times did this number pop up that I wanted? So that's the difference. Your data is right in front of you. Now, the first example I have here for us to do is with the number cube, okay? So a number cube is rolled and the results are listed in the table. So this is my outcome. I can get the numbers 1, 2, 3, 4, 5, 6, but now I actually wrote down how many times I got the number. So I got the number 1 4 times. I landed on 2 8 times. I landed on 3 6 times, 4 3 times, 5 4 times, and I landed on 6 times. Now, before I even get into the probability part, I know that the bottom number has to be how many times did I roll this cube? So to figure that out, I have to add up all of my trials. So let's add them up together. So just to be sure, because, sometimes I make mistakes and I don't want to make mistakes for y'all. So I have 4 plus 8 plus 6 plus 3 plus 4 plus 6. That gives me 31. So I just want to make sure. So total trials is 31. So I rolled this cube 31 times. So now that I know that, this is how we set up our experimental probability. So they're asking us to find the experimental probability of the following, and they give us 3. So this first one, it says, what is the probability of getting an odd number? So I'm going to use highlighter so we can distinguish. So here's my odd numbers is going to be in yellow. So here's my odd, odd, odd. Now in theoretical probability, I would really have to think about, okay, how many is that over how many total? Here I'm looking at the trials. So I have 4 times plus 6 times plus 4. So you're looking at the number of trials. So I landed on here 4, 6, that's 10, 14. So I landed on an odd number 14 times out of, how many trials did I do? 31. So I landed 14 times on an odd number out of 31. I can't simplify that, so I'm done. Okay? So experimental probability, the numbers are there for you to look at. And your data is right there. So let's take a look at the next one. Here they want the probability of a 4. I'll use pink. They want you to land on a 4. Here's my 4. And I landed on the 4 3 times. That's the important thing. Because the top number is how many times did I land on the 4? I landed on it 3 times out of a total of 31 rolls. That can't be simplified. So the experimental probability of me landing on a 4 in this example is a 3 out of 31 shot. Because I literally got it 3 times out of 31. So here you're actually doing the experiment. Now, the next one. I'll use green. They want a 2 or a 3. There's that word or. So I'm going to combine them. That means I want a 2 or a 3. So an 8 and a 6. Okay? Doesn't matter if I get 2 or 3 as long as I get one of those numbers. So we're going to add them. So 2, I landed on there 8 times. I'm going to show you here. Plus 3, I landed on it 6 times out of a total of 31. So add them together. I get 14 out of 31. That can't be simplified. So I landed on 2 or 3, 14 out of 31 tries. So again, you just have to make sure you're adding them together correctly. And you're looking at the trials. How many times did I land on whatever they wanted? So you don't have to do theory anymore. Now you're actually doing it. Let's go into the next one. So go ahead and copy that down. And these are the probabilities we'll be finding. And then press play when you're ready. Red. All right, so this example says the following spinner is spun 20 times. Ooh, that is my whole amount right there. That's the bottom number for all of these guys. The results are listed below. Find the experimental probability of the following. So I'm looking at the data here. I landed on A 8 times. I landed on B 4, C 5, and D 3, which totals 20. So somebody sat there 20 times, spun it, and recorded the data. Now we're going to go ahead and answer the probability questions. Here they want you to find the probability of landing on a B. Now, in theory, it would be 1 out of 4, but they want the experimental, and the experimental for landing on B was 4. Okay, I landed on B 4 times out of, remember, how many times did we spin this spinner? 20. Now, on this one, I can simplify 4 and 20. They're both even numbers, so I can definitely divide them out by 2. Okay, if you know of a bigger number, do the bigger number, but I'm just doing 2 just to, make sure everybody's on the same page. We'll all get the same answer. 4 divided by 2 is 2. 20 divided by 2 is 10. I can go again. So always ask yourself, can I simplify it again? 2 divided by 2 is 1. 10 divided by 2 is 5. Once you get that 1, you're pretty much done. So the experimental probability, of getting the letter B was a 4 in 20 shot, reduced down to 1 in 5. So please make sure on the Google form, your fraction is simplified to the lowest. If you put 420 or 210, it'll count it wrong. So be careful. Let's do the next one. The probability of a C or D. So C is 5, D is 3. So you add them together. So 5 and 3 is 8. So 8 out of 20. I should have skipped a line in between. That's going to be messy. 8 out of 20. I'm going to simplify these by 4. You could have done by 2 as well. 8 divided by 4 is 2. 20 divided by 4 is 5. So that one I had a 2 in 5 shot of landing on a C or D. Okay, and we're looking at the trials here. Next one is our vowel. So look at your trials. A is my only vowel, and there's 8 of them. Oh, look at that. I already did this one. I know 8 out of 20 is 2 out of 5. So the only vowel was A, and there was 8 times that I landed on A. out of 20. So 8 out of 20 reduces down to 2 out of 5. And the last one, letter Z. I do not see a letter Z, so you have 0% chance of that ever happening. This is definitely an impossibility. Impossibility. And that's experimental probability. Just make sure you look at the tables and the graphs. You're looking at the actual data, not the spinner. You're looking at the data that they've done this and they recorded it. So I want you to try this out. There you go. There's your try it out, and let's see what you get. Press play when you're ready. So a coin is tossed 50 times. I like when they tell me how many times they did it. I don't have to add. The results are recorded. Find the experimental probability of landing on heads. So I know the theoretical probability is 1/2, but here they're specifically saying experimental, which means I have to look at the trials they actually did. So the probability of getting heads, the experimental probability of getting heads, was 27 times they landed on heads out of 50. And that can't be simplified. The probability of getting tails was 23 times they landed on it out of 50. That's it. That's all there is to it on experimental. So pay attention. If they don't tell you how many times they did the experiment, please make sure you add correctly. Utilize your calculator at home to make sure you are adding them correctly. You're not making a mistake. If you have any questions, come to the Google Meets and I'll gladly assist you. Until then, I'll see you tomorrow. Bye.